Assalamualaikum and good day everyone. We are here to present our digital system to assignment. It is a 3-bit pack feeder. Our team consists of Nur Adila Syafiqah Binti Jaafar as a text and video editor, and then Nushaira binti Samsudin as circuit designer, and Nushaira Izami binti Muhammad Sa'ad as state table designer, and lastly is Maizatul Akmal binti Kamarudin as state diagram designer. Nowadays, many pet owners have busy schedules and may not always be available to feed their pets at the correct time. Because of this, an automatic pet feeder can be very useful to ensure that pets receive food regularly even when the owner is not around. The purpose of this project is to design a digital control system for an automatic pet feeder using sequential logic circuit. In this design, we use JK flip-flop to build as the primary control element to manage three variables, which is pet availability, food level, and water level. Unlike simple combinational logic, this sequential circuit maintains stable feeding or hydrating state, which prevents mechanical dispensers from chattering due to minor sensor fluctuation. Besides, we also created a state table determine the next which determine the next state transition. We also calculated the JK flip-flop inputs and simplify the logic using KMAP. And finally, design the digital circuit implementation.
We use JK flip-flops because they are reliable and prevent undefined state. The system active when the pet is present and levels are low, using the K input to reset once the cycle is complete. Looking at our project and state table, the system follows a clear sequence. It waits for the pet, checks the sensors, and dispenses food and water. We map this transition from state 000 to the final feeding state to ensure a smooth operation. To simplify our circuit, we use Carnot for each flip-flop input. For example, the input for J0 was simplified to Q1 multiplied with Q2 plus X, and K0 was derived as Q1 plus X bar. Using this expression, we developed our circuit design in quarters 2. Our functional simulation result and timing diagram confirm that the system transitions accurately between state 000, 001, 011, and 010 without any glitches. This proves our theoretical model is robust for a physical system. And this is our waveform circuit design. And this is our state diagram.
The main purpose of the circuit is to automate pet feeding using digital electronics. The system is designed to control a pet feeder without manual operation, making the process more efficient and reliable. We use JK flip-flops to store and maintain the current state of the system. This allows the feeder to follow a logical, organized sequence, ensuring it turns on and off at the right times. Overall, this design shows how basic digital components can be applied to everyday tasks, improving consistency and reducing the chance of human error. For the discussion, this project demonstrates the practical use of sequential logic circuits. The JK flip-flops allow the system to remember its previous state, which is essential for executing the correct feeding sequence. The benefits of the system are clear. It saves time, reduces mistakes, and ensures pets are fed consistently. Even if the owner is away, during testing the feeder performed as expected, confirming the system works reliably. In conclusion, this project shows how fundamental digital logic can solve practical problems. By designing a system with logic gates and JK flip-flops, we created an automated feeder that is reliable, efficient, and practical. This project also gave us the chance to apply theoretical knowledge into a working system, reinforcing our understanding of sequential circuits. Overall, the automated pet feeder demonstrates that even simple digital components can provide meaningful solutions to everyday challenges. That's all from us. Thank you for your time and attention.
And this is the simulation for our automated pet feeder, and we successfully get the result from our circuit.
And this is the result simulations for the task 1.